We've already learned how to use the distributive property to take a product of binomials and expand it first to a 4-term polynomial and then to combine like terms to a 3-term quadratic expression. This is called a quadratic expression because the highest degree term is a squared term. It is x squared. Now, we used FOIL to distribute our binomials, our first terms multiplied together to give us x squared, our outer terms multiplied together to give us 1x, our inner terms multiplied together to give us 3x, and our last terms multiplied together to give us 3. And finally, we combine like terms. 1x plus 3x gives us 4x. So obviously, if we can take a product of binomials and get it to a quadratic expression, if we were given just the quadratic expression here, we should be able to take it back to the product of binomials. We do this, we go backwards by factoring. So now what we're going to do is we are going to factor a quadratic expression. Now the generic form of a quadratic expression is ax squared plus bx plus c. You'll notice here in this example c is 3 because it is the constant term. It is the integer value. B equals 4 because 4 is the integer, the coefficient of the x term. And a in this example is simply 1 because there is no coefficient. So for our first type of example, we're going to set a restriction in which a can only equal 1. That's going to make it a little bit more simple. It's possible to factor quadratic expressions when a is our other numbers, 1, 2, 3, 4, 5, any number really, with limitations. But we're going to start with just a equals 1. So for our example, x squared plus 4x plus 3. We know that we want to factor it to a product of binomials. So we know we're going to have 2 big parentheses opened up to fit our binomials. And if we look back at how FOIL worked, we realize that this first term, this x squared term, was the product of the first terms of each binomial. So that means that we should go ahead and factor x. What 2 things can we multiply together to get x squared? And we realize that x squared is x times x. So our first terms should be x and x. And then when we look back up at how FOIL works, we realize that this 3, this last term, came straight from multiplying the last term of each binomial. So we realize that if we were to factor 3, we would know the numbers that should go in the last position of our binomials. Now we should realize that 3 can be factored into 3 times 1 or negative 3 times negative 1 because a negative times a negative is also a positive. So we know that there's going to be the integer 3 and the integer 1, but we're not yet sure if it's positive 3 or positive 1, or if it's going to be negative 3 with negative 1. So then we look up and we realize that before we got to our quadratic expression after using the distributive property, we had to combine like terms. When we combined like terms, we added 1 and 3 to get 4. So we realize that if we take the factors, the factors of the third term should add up to the coefficient of the second term. So if I ask myself, if 3 plus 1 equals 4, so that's good. What about negative 3 plus negative 1? That equals negative 4. Because I want a positive 4, I'm going to choose positive 3 with positive 1. Positive 4 was what I wanted, so I choose positive 3 and positive 1, the factors of my third term.